And welcome back. This is the second part of the exam marking period 2 quarter exam review sheet A. We're on the back side going through problems 8 through 15. And the reason I wanted to stop where I did is because this is getting into more of the modern stuff, the stuff we just did last section. So remember, extraneous solutions occur when there's an x underneath the radical, when there is an x in the denominator, and when there's an x in the absolute value. There are 3 problems on your exam that are like this. These are the ones you want to check for extraneous solutions. So remember your square root, x in the denominator equals something, and the absolute value. They are the only 3 you're going to have to check. So starting with one of them, number 8, the square root of 3x minus 2 equals x minus 4. And I picked this problem purposely because it was one that a lot of people got wrong on the quiz. So the first thing you want to do is use 3x minus 2 equals x minus 4 is you want to square both sides of the equation. Remember, there's a little index number 2, and a lot of people got that part right. So you cross this out, you cross this out, and you bring down 3x minus 2 equals x minus 4 squared. I'm going to write that down here in red. X minus 4 squared does not equal x squared minus 16. X minus 4 squared is the same thing as x minus 4 times x minus 4. Be careful of that. And if you FOIL out x minus 4 times x minus 4, you will get x squared minus 8x plus 16. It's going to give you a completely different answer. And even if you get x squared plus 16, you're going to get one answer right, but you're going to be missing the other one. Another common mistake is right here. A lot of people said, okay, well, 3x minus 2 equals 0, and x squared minus 8x plus 16 equals 0. That's not how that works. What you need to do is make sure it's set equal to 0 first. And to do that, we're going to subtract 3x from both sides, and we're going to add 2 to both sides. And when we do that, we're going to have x squared, negative 8x minus 3x will be negative 11x, plus 18 is going to equal 0. Now you want to factor this out. When you factor this out, you'll get x minus 9 times x minus 2 equals 0. Setting each of these equal to 0, you'll get x equals 9 and x equals 2. And these two, we're going to plug back into the original equation and check them out. So if we do the square root of 3 times 9 minus 2, that's going to be 27 minus 2, 25. The square root of 25 is 5. Equals 9 minus 4, which is just 5. So 9 works out. If we plug 2 in, so it's going to be the square root of 3 times 2 minus 2 equals 2 minus 4. So it's going to equal negative 2. At this point, you know 2 isn't going to work because at no time does a square root of a number ever equal something negative. But just to keep showing it, it's going to be 6 minus 2. Square root of 4, 2 equals negative 2. It does not. Therefore, 2 is wrong. And the solution on your quiz is going to be x equals 9 with an extraneous solution of x equals 2. This is going to be one of your fill-in-the-blank questions. So number 9 then, another one, we have an x in the denominator. It says solve x minus 2 over x plus 1 plus 3 times x squared plus 3x minus 4 equals 1. So what we want to do here is we want to factor out the denominators and find what our LCD is. So x minus 2 and x minus 1 are both completely factored. It's going to be plus 3. X squared plus 3x minus 4. So what factors of negative 4 add up to 3? Well, that's going to be a positive and a negative. Let's see, let's do positive 4, negative 1. And that works out, and that's going to equal 1. So our LCD here is picking something from each denominator. So from this one, we have an x minus 1. We go over to the second term, and we say, hey, we have an x plus 4. We already have an x minus 1, so we don't need that. The 1 is just by itself. It's 1 over 1. So our LCD is going to be x minus 1 times x plus 4. And what we're going to do with this LCD is we're going to multiply the entire expression by x minus 1 times x plus 4. So when we distribute that to the first term, what we're going to do is say, okay, we have an x minus 1 in the denominator. That's going to cancel out. So we're going to be left with x minus 2 times x plus 4. Our second term, the 3, has an x minus 4 and an x minus 1 in the denominator. They're both going to cancel out with the denominator. So we're going to be left with 3. And this is the big point where people missed on the last quiz, is you have to distribute it to the 1 as well. So this is going to equal x minus 1 times x plus 4. And now here you want to do the same thing or something similar to what you did with number 8. So you want to FOIL this out. We get x squared. X times 4 is going to be 4x minus 2x. So we're going to plus 2x minus 8 plus 3. And that's going to equal x squared plus 3x minus 4. Combine like terms on the left. We have x squared plus 2x minus 5 equals x squared plus 3x minus 4. And now we want to get everything to equal 0. So what I'm going to do is I'm going to subtract the left from the right. So we're going to subtract x squared from both sides. I'm going to subtract 2x from both sides. And then I'm going to add 5 to both sides. So what we get there is then we're going to have 0 equals x squareds are going to cancel out. 3x minus 2x is just going to be x. Negative 4 plus 5 is going to be positive 1. Well, there's nothing left, so we just now have to subtract negative 1. So we get negative 1 equals x. Because there's an x in the denominator, we need to check, make sure that it's not an extraneous solution. I'm going to do it by hand quickly. So you get negative 1 minus 2 over negative 1 minus 1 plus 3 over negative 1 squared plus 3 times negative 1 minus 4. Well, negative 1 minus 2 is negative 3. Negative 1 minus 1 is going to be negative 2. And we have negative 1 squared is going to be 1. Positive 3 times negative is going to be minus 1. Or minus 3 rather, I'm sorry. Minus 4. So 1 minus 3 is a negative 4. Negative 4 minus 4 is 8. So this becomes 3 halves minus 3 over 8. Getting an LCD, this turns into 8 times 4 times 3 is 12 eighths minus 3 eighths. I did my math wrong somewhere. Well, anyway, it does work out to 8 over 8. I don't know exactly where I got my math wrong. 1 plus negative 2, negative 3. -1 plus. If you plug it in the calculator, it actually works. I promise you, I guarantee you that. And I can't edit out because this is going to YouTube. One minus 3 is 2. Okay, there it is. There it is. There it is. This doesn't come out to 8. It's positive 1 minus 3. Comes out to negative 2. Negative 2 minus 4 is 6. I'm just going to erase this whole thing here. So you get 3 halves plus something over 6. You get 3 over 6. 3 6 is 1 half. So 3 halves plus 1 half equals 4 halves, which equals 2. And that 2 does not equal 1. You know, I'm just going to cut this. No, I'm not, because that's a negative 6. This is what y'all don't see. So 3 halves minus 1 half is 2 over 2, which equals 1. So I'm going to try to cut out that beginning segment. If you see this, sorry. All right, number 10. Now we've gotten through that. 2x cubed equals x to the 4th minus 3x squared. So this one, we're going to move the 2x cubed to the other side of the equation. Doesn't matter where we put it. And what we're going to have that is x to the 4th minus 2x cubed minus 3x squared equals 0. Step 1 when you're factoring is always pull out the GCF first. So we're going to have x squared. There's no constant, so it's going to be x. So then we're going to be left in the parentheses with x squared minus 2x minus 3 equals 0. See if this factors out. X squared. Well, factors of negative 3 that add up to 2. Negative 3, positive 1 equals 0. And then set each factor equal to 0. One thing people missed on the quiz was this x squared out in the front. So if x squared equals 0, x equals 0, x equals 3, x equals negative 1, and your final solution is x equals 0, 3, negative 1. Number 11, we have an x in the absolute value. This is the last type of problem that can create an extraneous solution. A large number of people missed what you're doing. Remember that the absolute value of negative 5 equals 5, and the absolute value of 5 also equals 5. So what this is saying is whatever comes out into the parentheses can be negative, but you don't change what's in the parentheses, you're going to change what it's equal to into a negative. So I'm going to draw my arching tree. We have x squared plus 6x equals 3x plus 18, and x squared plus 6x, and I'm going to do it the long way, equals negative 3x plus 18. When we solve this one on the left, subtract your 3x from both sides, so you get x squared plus 3x minus 18 equals 0. And then try to factor that one out. This factors out factors of negative 18 that add up to 3. So we x, say positive 6, negative 3. That works out. So each of these equal to 0. So x equals negative 6, x equals 3. Over here on the right, there's going to be an extra step. So x squared plus 6x equals negative 3x minus 18. Bring everything over to one side gives x squared plus 9x plus 18 equals 0, which means our signs are going to be plus plus. We have our x's in the front. Factors of 18 that add up to 9. Positive 6, positive 3. So equals 0, equals 0. So x equals negative 6, and x equals negative 3. And now we have to go through and check each of these in the extraneous solutions. So if we put negative 6 back into the original equation, negative 6 squared is 36. Plus 6 times negative 6 is going to be 36. So 36 minus 36 is 0. 3 times negative 6 is, so we're going to have a 0. 3 times negative 6 is negative 18. Negative 18 plus positive 18, 0. So negative 6 is going to check out. Plugging 3 in, 3 times x, 3x squared is going to be, or 3 squared is 9. 6 times 3 is 18. 9 plus 18 is going to be 27. 3 times 3 is 9. 9 plus 18 is 27. So 3 checks out, okay. And then negative 3 squared is 9. 9 plus 6 times negative 3. 6 times negative 3 is 18, or negative 18 rather. 9 minus 18 is negative 9, but the absolute value of negative 9 is positive 9. And then 3 times negative 3 is negative 9. Negative 9 plus 18 is 9. So negative 3 checks out. Therefore, your solution set is x equals 6, positive and negative 3. Number 12 then, x squared plus 3x equals 9. Just like we've been doing before, set it equal to 0. So you add 9 to both sides. You have x squared plus 3x plus 9 equals 0. And if you look at this and say, okay, can we factor it out? Well, there's no factors of 9. They're going to add up to 3. You have 1 and 9 adds up to 10. 3 and 3 adds up to 6, meaning this does not factor. Because it doesn't factor, you want to use the quadratic formula. X equals negative b plus or minus the square root of, that's supposed to be a b, not a 6. B squared minus 4ac all over 2a. And remember, the numbers we're talking, the variables here are going to be your coefficients in front of each variable. So think ax squared plus bx plus c equals 0. So then our b is going to be negative 3 in the front there because of the negative sign, times the square, plus or minus the square root of b squared. So that's going to be 3 squared minus 4 times 1 times 9 all over 2 times 1. And this becomes negative 3 plus or minus the square root of 9 minus 36 over 2. At this point, I'm going to split up my 2. So I have negative 3 over 2 plus or minus the square root of negative 27 over 2. Square root of negative 27 is going to become I times root 9 times root 3. So 3I root 3. So this equals negative 3 halves plus or minus 3I root 3 over 2. And at that point, you are done. And it's really cool because if you look at this, it's an x squared, and we said the highest degree determines the number of solutions, and there's your 2 solutions. Number 13, simplify 27 over 64. This is one that you plug into the calculator. So what you want to do is you want to enter the buttons just like this. You're going to do open parentheses, 27, division, 64, close your parentheses, raise to, or your caret, and then open your parentheses, do your negative sign, not your minus sign. I'll put that in the parentheses so you know it's like the negative. 2 divided by 3, close your parentheses, and then lo and behold, you are going to get some ridiculous decimal. I'm going to look it up right now. So 27 divided by 64 raised to negative 2 divided by 3. And you're going to get 1.777 forever until it goes to an 8 at the end. What you want to do is you want to go to math. And the first thing here, the number 1, says number, and there's a little darkened arrow. It says fraction. Hit that, it'll automatically plug in your answer, and it will give it to you as 16 over 9. So that's a nice quick problem. Number 14, I mistyped. It should look like the one on the right here, but I'm going to do both of them here just so you can see what this is like. So 4x to the 1/2 times 4x to the 2/3. Simplify and write with rational exponents. That's no big deal. So what we're going to have is 4 times x to the 1/2 times x to the 2/3, because multiplication is commutative, so we can shift it around. 4 times 4 is 16. When you multiply variables, you add the exponents, so it's x to the 1/2 plus x to the 2/3. And this is 16x. We have to find a common denominator, which is going to be 6. 1/2 is 3/6, 2/3 is 4/6. So we have 16x to the 7 over 6. And that one would be done. If you did it like this one on the right, which is going to be the one that's on the quiz, you will have 4x to the 1/2. And then this on the right is going to distribute the 2/3 to each of the statements. So it's going to be 4 to the 2/3, x to the 2/3. Meaning this is going to be 4 times 4 to the 2/3 times x to the 1/2, x to the 2/3. Well, remember, any number is raised to a power of 1. Any number to the first power is itself. So this is technically 4 to the 1 plus 2/3, x to the 1/2 plus 2/3. Another way to write 1 is 3 over 3. So it's 4 to the 3 over 3 plus 2 over 3. X we did over here on the left, so it's going to be x to the 7/6. And then this 3 to the thirds plus 2/3 is going to be 4 to the 5 over 3, x to the 7 over 6. Not too much different from the first answer, but really be careful and look for where your parentheses are, because obviously I didn't when I typed this up. And last but certainly not least, rationalize 8 minus I divided by 1 plus 4i. What you want to do is, remember, you want to multiply by the converse. So I'm going to start down here. And what the converse means is you're just going to rewrite your denominator. So it's going to be 1 for I, 1 for I, and swap your signs. So it's going to be 1 minus 4i over 1 minus 4i, because that's a unit of 1. Now you're going to factor this out. I like to put parentheses just so I can see that they're factors, so I don't mess anything up. It reminds me to FOIL them out. 8 times 1 in the numerator is going to be 8. 8 times negative 4i is negative 32i. Negative I times 1 is negative I. Negative I times negative 4i is going to be plus 4i squared. And in the denominator, we have a difference of squares. So this can become 1 squared, which is 1, minus 16i squared. And one cool trick that, the more you do it, the more you can see it. Remember, I equals the square root of negative 1. So I squared equals negative 1. All I squared does is change the sign of whatever numbers it's associated with. And I'll work it out, but just moving forward. Combine your like terms, so it's 8. Negative 32 minus I is going to be negative 33I plus 4 times negative 1 over 1 minus 16 times negative 1. When you simplify that, you get 8 minus 33I minus 4 over 1 plus 16. Notice when we change the i's from up here to down here, it just changed from positive 4 to negative 4. A negative 16 just turned to a positive 16. Not incredibly helpful, but figured I'd show you. Now remember, we want to get in the form of a plus bi, because I can't be with it because it's imaginary. So we need to have our constants and our i's separated. 8 minus 4 is going to be 4 minus 33i over 17, which means our final answer is 4 over 17 plus or minus 33i over 17. That's it. So that is the end of the review sheet for exam review sheet A for the marking period 2 exam. If you have questions, please email me. If you have any concerns, this covers pretty much every problem that I can think of that you'll have on the exam. If you look at the marking period 2 exam in the Google Classroom and see one that you don't know how to do, email me or ask me Tuesday or Wednesday, hey, can you go over that? And I'll gladly work through it with you. But if not, this is the end of the video. Enjoy your day, enjoy your weekend, and I can't wait to see you all Thursday.